Thank you very much for letting us come here and have this talk and have a fantastic time. Well, I'm really here to tell you that I hate sea urchins.
Not really.
Along the Norwegian coast, barren grounds are dominated from approximately 65 degrees north and northwards, and dominated by the strong Lytzentrotus ströbackensis. And the barren grounds are extended into Russia. South of this border, kelp forests in pristine states are still dominating. This very large-scale grazing event was first reported by fishermen around 1970. And it was later documented that nearly 2,000 square kilometers of kelp forest was grazed, and only remained in the outermost wave-exposed areas. There has been reported several local collapses in sea urchin populations and recovery of kelp, and the other way around, but largely the barren ground area has remained stable for now more than 4 decades. The extent is huge. At the moment, approximately 1,400 square kilometers of kelp forest is grazed, and this is a loss of approximately 17 million tons of kelp of standing stock. It also represents a high loss of diversity, habitats, and nursery area for fish. We have done a lot of studies within the pristine kelp forest stage since the 1990s. And we have, for instance, found that on each square meter we found approximately 100,000 invertebrates from between 200 and 300 species. But most of the production, approximately 90%, is exported from the system, and it's not utilized within the kelp forest system. It's fragmented and accumulated on shallow and deep water. And you can actually find accumulations in canyons down to 1,500 meters with high densities of crustaceans. So you can say that the kelp forest system is important for the larger coastal ecosystem. And kelp forest is also a potentially important carbon dioxide sink. The lost kelp forest could fix a substantial amount of carbon dioxide, and also via the fragmented export material, as some part of this will be buried in sediments on deep water and is there lost from the carbon cycle for a long time. Okay, several theories have been suggested controlling sea urchin populations on the Norwegian coast, and not all of them are scientifically based. There has been suggestions of disease control, control by nematodes, Echinomarmella nematodes, climate variation, predation on sea urchin larvae in the pelagic, and macropredation by trophic cascades including harbor seal, wolffish, and adult sea urchins, and also micropredation including trophic cascades with cod, crabs, and small sea urchin recruits. So as a starting point in our project, we reviewed some of the studies that have been done to see what is the status of knowledge. And we could conclude that disease is not the controlling factor for sea urchin populations. The Veterinary Institute has tested on several microorganisms, and there's no correlation with disease and collapse in sea urchin populations. Also, there is no correlation between nematode parasites and collapse in sea urchin populations. However, they get more vulnerable when they are heavily infected. So that may be a co-warring effect. Also, there is no hold to say that predation on adult sea urchins are important, at least not by wolfish. This is a theory proposed by people that wanted to shoot seals, I guess. You know, Norwegians, they want to shoot everything with a pulse. And there is no evidence for saying that there is a top-down control on seals on wolfish and on wolfish on sea urchins. And also the collapse in wolfish populations occurred after the outbreak of the sea urchins. So the remaining theories, sea urchin show that during the outbreak there was a very cold period in the late 1960s. And well, we have no data really on the predation in the pelagic, but the herring stocks, they collapsed around the same period when the sea urchin population exploded. And interestingly, there is some important similarities between the ecosystem we have in the Northeast Atlantic as the one they have in the Northwest Atlantic. And there is a possibility that there is trophic cascades including cod, culture crabs, and small sea urchin recruits. Since the 1990s, there has been a recovery of kelp forest in the southernmost area of the Barren Ground area. And the southern border of the Barren Ground area has moved 270 kilometers northward. And kelp has recovered in an area nearly as large as 500 square kilometers. And although it's perhaps too late to identify the causes to the grazing event happening 40 years ago, this is a unique opportunity to study the system during a shift. So this was important to us. And we asked 3 basic questions. To what extent can lack of reproduction explain sea urchin population crash? And can lack of settlement explain collapse? And the third one was, can lack of post-settlement recruitment processes? Or can post-settlement recruitment processes explain the population crash? It is tempting to think that this has something to do with climate change. The water temperature has increased 1 or 2 degrees since 1985, and this figure shows the temperature within the 3 different periods when the kelp forest recovered in this area. And the temperatures in the spring is in the area which may be critical for sea urchin development, the larva development. However, there may be something more to it, because we still find pocket populations of sea urchin south of the border, which seems to survive well. And to the first question, we compared the gonad index for several populations of sea urchins in the northernmost area, Hammerfest, where the sea urchin hold the grounds and there is no recovery of kelp at all. And we compared it to the Vega area in just at the border when kelp is recovering. And we did not find any difference in the gonad index. And also there were no correlation between local gonad index and settlement into standardized sampling units. So this seemed not to be driven by local reproduction. And to the second question, we compared settlement of sea urchins into standardized sampling units, that is pan scorers, placed in dense kelp forest and on barren grounds, which are the gray ones, in Hammerfest and in Vega in 3 subsequent years, and also during different seasons. We don't have a monitoring program, but there was a striking difference between the settling in these 2 areas. There were nearly no settlement into the sampling units at the Vega area where kelp is recovering. But there is also other large-scale changes going on with global warming. And crab populations, Cancer crab populations are increasing fast and extending further north. And it's now as far north as Hammerfest. And this figure shows, this is fishery data of crab and cod catches just in the area of Vega where kelp is recovering. And 2007 was the year when the southern border were identified at Vega. So the crab populations are increasing fast, and at the same time, cod populations are decreasing. And also interesting is that in the eastern part of Finnmark, that is the most northeast part of Norway, where the water is the coldest, Kamchatka crabs, which is an invasive species from Russia, has invaded the Norwegian coast. And it has sea urchins on its menu. And in this area, we have, for the last few years, seen local recovery of kelp forests. But this is more observations than hard data. And to the third question, to what extent post-settlement predation can explain sea urchin population collapse? Camilla, she performed predation experiments in the lab using juvenile cancer crabs and other potential sea urchin predators, feeding small sea urchins. And she found that cancer was the one that ate most sea urchins. But of course, to increase the realism of such an experiment, we also tried some tethering experiments. And we penetrated with a cannula sea urchins, small sea urchins from the mouth up to the anus, and tethered them with a thin fish line to a plastic plate. And they were followed by a surveillance camera. And we found quite high activity, especially during night, of, in this case, carcinous crabs, but also cancer crabs. Are they about to start arguing with each other? But we didn't find any difference between barren grounds and kelp forests, which we expected. But this may be a difference in the bias of using tethering experiments. For instance, that these sea urchins are perhaps more visible out on the barren ground than inside a dense kelp forest. So back to the questions. So far, it seems that reproduction does not explain the collapse in the sea urchin populations, while lack of settlement may be. And in addition to this, increased predation on small sea urchins is probably also important. So it seems that global warming is affecting sea urchins directly in the pelagic phase, and also indirectly by increasing predation. Well, most of these results are taken from the Restore project, which is a cooperation between NIVA, the University of Oslo, and the universities of Roskilde and Aarhus in Denmark. We are also very proud of our reference group with Daisuke, he's sitting there, and also Professor Robert Stanek and Ken Dunton from Maine and Texas, respectively. And we started our meeting at a workshop in Bekkjarvik, out in the archipelago on the west coast of Norway. And actually, the chef of this hotel, he won the Bocuse d'Or this year, which is the Olympics for chefs. So just let you know, if you are ever invited to Norway, you should come. Our kelp forest group at NIVA is quite large. Camilla is the hero, the hard-working PhD. She's sitting there. She's working on finishing her PhD now, but we are a lot of other people and scientists working with the kelp forest in a group around Hartvig Christie. So thank you very much for listening.